everybody. My name is Jim, and I am an educator performer at the Denver Museum of Nature and Science. So today, as part of our Denver Museum Nature and Science Party, I'm here to demonstrate some properties of the phases of matter. So what do we mean by matter anyway? Well, it's anything that's made up of atoms and molecules. Okay? And it can be almost anything, but there are three major forms. There's a few others that I don't have access to at the moment, but the three major types of matter. First is solid. Okay? Solids are things like, ping pong paddles and balls. Okay? Very solid. TV remote controls, kettlebells, okay, very solid stuff. Telephones, yes, this is what we used to call a telephone, so punch buttons and everything. All right, so these all have a very definite, let me bring this back, these all have a very definite size and shape. Okay, once it's made, once it's put together, that's pretty much it. It's not going to change anything very much at all without some extreme forces being applied to it. So that's because the molecules inside are just kind of vibrating. They're not really going anywhere. They're just kind of moving. They have a certain amount of energy to them, but they're not doing anything really. The next phase after solids comes liquids. If you add a little more energy to the molecules of a solid, you get a liquid, like the colored water inside this bottle here. Okay? Now, liquids maintain a constant volume, just like a solid. I mean, if I were to pour all of this out, it would hold the same volume. The volume that I poured out of this is the same volume that's in here, but they're not the same shape. Okay? In fact, I can pour it into here, and it takes even a very different shape altogether. Okay? So, liquids have a very definite volume, but a very indefinite, a very adaptable shape that those molecules can take. Okay? And that's because their increased energy levels mean that they can actually slide against each other. They're moving around, and they can move. All right, so they can adapt to the shape of their container. The third type of matter, or third phase of matter, is called a gas. Now this is a balloon inflator here. What I'm going to do is take just an ordinary balloon, take it here, and I'm going to put in, let's say, 1, 2, 3, 4 pumps. Okay? And you can see it takes on this shape and this size. Okay? All those molecules of the air that were inside here are now occupying a very different volume and a very different shape. We can show that again by taking a different container of different volume and shape, and we go 1, 2, 3, 4. Okay, very different volume, very different shape. That's a gas. In fact, as I let the air out of these balloons, and it starts to enter the room here, those molecules will spread out and fill the entire space of this whole room. So gas molecules are just zipping around. They have so much energy, they're just zipping around everywhere. So they will fill all sorts of volumes. They will fill with the volume of whatever container they're in and take whatever shape. Okay? So solids, definite shape, definite volume. Liquids, definite volume, no definite shape. Gases, no definite shape, no definite volume. But there are some things that don't fit any of those categories. or at least they fit some of the categories some of the time, but not others. One of the most famous ones is called, commonly referred to as oobleck. In science, we refer to it as a non-Newtonian fluid. Okay? Newtonian fluids are like water. Okay? Regardless of how much pressure you put on them, they're still going to flow at a certain rate. Okay? So, the deal is, though, with non-Newtonian fluids, that if you change the pressure on them, they will be in one state, one phase of matter, but if you change the pressure, they will exist in a different state of matter. So, for example, with oobleck here, which is basically just cornstarch and water, you can see that as long as I'm applying pressure, that this is maintaining a solid shape, okay, more or less. Okay, I'm not applying constant, steady pressure since I'm moving it around, but you can get the idea here, okay? Now, if I suddenly release that pressure, bump, look what happens to it. It just starts flowing like a liquid. So there you have it. Not all matter reacts the same. In this case, we call it a non-Newtonian fluid. It can exist in different states of matter depending on the conditions affecting it. Which brings us to an interesting question then for further investigation. What about cats? Are they solid or liquid? What do you think? Okay. Thank you for joining me today. This is Jim, educator performer at the Denver Museum of Nature and Science. Thanks for joining me.